Okay, so we are going towards next question. That is question number 17. Program to find sum of n numbers. Program to find sum of n numbers. Again, I am taking copy 16.asm to 17.as, and I am changing the contents of 17.asm. So our question is to find the sum of n numbers. I need to find sum of n numbers. That is, if I am giving 10 numbers, I need to find out the sum of 10 numbers. So for that, we need to create 10 bytes. That is A1 dB 65H, 23H, 21H, 24H, 12H, 12H. Okay. Likewise, we can give the bytes. So 01H, 02H, 03H, 04H, 05H, 06H. Okay. So I have given 6 numbers. Okay. Now I need to give the count. How many numbers I am using? So I can give A2 dB 6 here. So if I change the numbers to 10, then I need to give the corresponding counter. So there is one more way to get the number of bytes we have given. That is, A1 contains the address of the starting address, and we have a symbol called $, which indicates current address of A2. So A2 dB $ minus A1. This will give the number of bytes. Current address minus address of A1 will give the number of bytes also. Either we can give the n here using this by counting. If I have given 10 numbers, I can give a count of 0n. Or if I use like this, then I will be getting the number of bytes I have given in the earlier line. $, stands for current address minus A1 is the first address. So this is $, minus A1 means I will be getting the count of this, how many bytes I have given. This works only in data set. Now I need to store the answer. The answer can be 16-bit. So I am defining two variables. One is A3 dB 00H and A4 dB 00H. So I am reserving two variables A3 and A4. A3 is for storing the sum, and A4 is for storing the carry if produced. So whenever a carry is produced, I will be incrementing A4. I will be incrementing A4 to store that there is carry. Okay. So we have two variables A3 and A4 for storing the answer. Again, coming to logic. As we always do in high level language, S is equal to S plus array location. S is equal to S plus A of I. Here also we are going to use the same logic here. So I am using a memory pointer It can be SI or DI or DX. So I am using SI for pointing towards memory, because in that collection of bytes we have only one name as A1, that is the first location. Then the locations succeeding that A1 does not have addresses. We need to does not have names, variable names. We need to refer them using the addresses only. So I need to add the numbers n times. So we have n in A2 now. We have the number of numbers in A2 now. So I am moving this A2 to CL. So I am loading the count in CL, and I am making CX as 0, 0. In order to remove the random value in CH, I am making it as 0, 0. And in CL I am loading the actual count. Okay. Now I need to do the operations CL number of times. So first I am pointing the SI towards A1. So LEA SI comma A1 means the address of A1 is now available in SI. SI is a 16-bit register. A1 is an address or offset in the data segment. So both are 16-bit. So LEA SI comma A1 means we are storing the offset address of A1 to SI. Okay. Now I am going to use a register for addition. For storing the answer, it is I am using move A L comma 00H, and I am making register move AH comma 00H. So my idea is to get the sum in AL, and whenever a carry is generated I will be incrementing AH to accommodate the carries. So each time I will be checking if there is carry. So if a carry is generated, I will be incrementing this AH to accommodate the carry. So I have the pointer towards A1 now. I have two variables, two registers for storing the sum also, and I am using add AL with the contents of SI. Contents of SI means the contents of the memory location pointed by SI. So add AL comma SI means now add AL. AL is now 0, 0. Now add AL with the value stored in memory which is pointed by SI. And this will be the line will be executing n number of times. And so I am using a logic called jump on non-carry. If there is no carry, jump to n1. If there is a carry, then increment AH. So during addition, whatever value stored in AL will be added with the value pointed by SI in memory. And during the addition, if there is no carry, then proceed to N1. And if there is carry, then increment AH. AH is a register for storing the carry, and so increment AH and then proceed to N1. Here we have to make the pointer towards the next location. We have to make the pointer move towards the next location. So I am incrementing SI to make the pointer towards next location. Increment SI, and I need to do this operation CL number of times. So I am using the instruction loop again. So I need to give a label where to loop. So here it is for loop again, and so it loops this CL number of times. So CL is the number of times, number of bytes. Okay, and so after this looping, the answer will be stored in AL and AH. So I have two variables in memory. One is for storing sum, and for storing carry. A3 is for storing sum and A4 is storing carry. So I am moving this answer A3, answer of AL to A3. So move A3 comma AL and move AH comma A4 comma AH. So I have moved two answers to memory. Okay, I have saved the program. The data given is 01, 02, 03, 04, 05 and 06. For the time being I am removing this 06. So the sum will be 9 plus 3 is 0C, 0C plus 2 is 0D, 0E and plus 1 is 0F. Okay, we should get the answer 0F with no carry. We'll see what happens. Sum 17 dot sum. Okay, link 17 debug 17 dot exe g. Okay, we'll check for the answer D0000. Show me up to 10. Okay, so the input was 01, 02, 03, 04 and 05, and the count you can see it is 05 that we have made by using the dollar minus A1, and the answer is in the next location as 0. Okay. And if I change numbers, again either change the number of numbers, then also there is no need to change the count because I have given as dollar minus A1. So the current location minus A1 location gives the count in data segment. Okay, so I can add numbers here. 0FH, FFH. Okay, so this will produce a carry because FF plus something. Okay, we'll see. Okay, in that array, symbol not defined as FF because F is a character, and so the assembler is not able to identify whether it is a number or string, and so we need to prefix a 0 to indicate that it's a number. So 0FF, the value taken is FF. That 0 is given to indicate that it is a number, not a string. Okay, so I am compiling this, assembling this, then link 17, okay, debug 17.exe, execute this, and I am checking the answer for 10 locations. Okay, so we have 1, 2, 3, 4, 5 F and FF. So we have 7 numbers, and the answer is 1D01. So the LSB is 1D and the MSB is 01. So we need to read the answer as 01 1D. So as I told, it has produced a carry. Okay. So this is the logic for finding out the sum of n numbers. Okay.